Hello everyone. We now have a question which is based on the VSEPR theory. So we have to predict the shapes of SO32 minus, CO32 minus, BrF4 minus, these three molecules according to the VSEPR theory. So I have my previous videos where I have solved such questions based on the VSEPR theory to predict the shapes of the molecules. You can refer to those videos and we will follow the same steps to predict the shapes of these molecules. Okay, so let's begin. So we have the first one. Let me write it as the first, the SO32 minus. Okay, now we have to, first of all, what was the first step? We have to identify the central atom. So we know that O3 cannot be the central atom here. So there are few rules that only the atom which is least in number and which is then we have to compare the electronegativity. If there are atoms with similar numbers of atoms, then we have to compare their electronegativities and so on. Okay, now here we have the sulfur as the central atom. Now what is the valence electronic configuration of sulfur? Sulfur belongs to the oxygen family. Okay, we know that very well. That means it will have Ns2 Np4 as the valence electronic configuration. That means we have 4 plus 2, that is equal to 6 valence electrons. So number of valence electrons in sulfur is 6. Then we have to write the number of electron pairs gained from oxygen. Oxygen, that means the bonded atoms. So the number of electrons gained from any bonded atom. So here we have 3 oxygens bonded, but at the same time, if you remember in my last videos, in my previous videos on VSEPR theory, I have mentioned that whenever there is a probability of a double bonded oxygen, then we do not count these electron pairs gained from the bonded oxygen, which is doubly bonded. So here also we know that SO3 has doubly bonded oxygen. So in this case as well, the number of electron pairs gained from oxygen will be 0. Okay. Then next we have the total number of electron pairs. So total number of electron pairs are counted by adding the number of valence electrons in the central atom, then the number of electron pairs gained from the bonded atoms, as well as what else we have? We have a negative charge as well. So we have to add 6, the valence electrons in the central atom sulfur. Then the number of electrons gained from oxygen is 0, and then we have 2 negative charges. This is divided by 2 because we require the electron pairs. So that is why we divide it by 2. We have 4 electron pairs. Now we calculate the number of bond pairs. So here we can see 3 oxygens are bonded to sulfur. Okay. And that is why the number of bond pairs will be 3. Now you must also remember that we have mentioned that oxygen is doubly bonded here, but when we have a doubly bonded oxygen, then in these double bonds, one of the bonds is the sigma bond. So that is why we have to consider these sigma bonds for 3 oxygens. 3 oxygens doubly bonded, 3 sigma bonds. That is why the number of bond pairs is 3, because VSEPR considers only the sigma bonds and not the pi bonds. And then we have to calculate the number of lone pairs. For that, we have to subtract the total number of electron pairs minus number of bond pairs. So 4 minus 3 is equal to 1. We have 1 lone pair. Now we very well know from our previous knowledge that if we have the total number of electron pairs, then the electronic structure will be a typical tetrahedral. But if this tetrahedral has a lone pair, a single lone pair, then this tetrahedral gets distorted. So it distorts to which structure? It distorts to a pyramidal structure. Okay, just like ammonia. So it has a pyramidal structure. So SO32 minus, because of this single lone pair, is a pyramidal structure. So do we have pyramidal in any of these options? Trigonal pyramidal, yes, correct. Trigonal planar, no. Trigonal pyramidal, trigonal planar. Okay, so out of these four, there is a probability that either first or the third could be the correct option. Now let's move on to the second molecule, that is carbonate, CO32 minus. Now we have the central atom very clearly visible, carbon, and carbon has 2s2, 2p2 as the valence electronic configuration, giving rise to 2 plus 2, that is 4 valence electrons. Okay, then again we calculate the number of electrons that is gained from the bonded atoms. Bonded atoms are 3 oxygens, and these also have a probability of a double bond. So the number of electrons gained from oxygen in this molecule carbonate will be 0 because of the presence of the double bonded oxygen. Then the total number of electron pairs we calculate by adding the number of valence electrons in carbon, 4. Okay. Electron gains from oxygen, 0, and then we have 2 negative charges divided by 2, that is 3. Okay. So the total number of electron pairs in carbonate is 3 electron pairs. Now the number of bond pairs. We can see here 3 oxygens which are bonded to carbon. And as I mentioned, these are doubly bonded oxygen, and that is why they have 1 sigma and 1 pi bond. So 3 oxygens, 3 sigma bonds, which are considered for VSEPR theory. So the number of bond pairs will be 3. 3 sigma bonds for 3 oxygen. Now the number of lone pairs. So we know how to calculate it, subtracting the number of bond pairs from the total number of electron pairs. So 3 minus 3. So both are same. We have no lone pairs here, 0 lone pairs. Now a structure which has total number of electron pairs 3 will give a typical electronic structure, which is the trigonal planar structure. Okay. So let's check if we have a trigonal planar option in the question. Okay, so trigonal pyramidal was our first one. Second is trigonal planar, trigonal planar. Yes, equal probability for option 1 and 3. Both have trigonal planar for CO32 minus. Then, okay, then we can decide our answer by checking the BrF4 molecule. Okay, now let's go to the BrF4 minus structure. Now for BrF4, bromine is the central atom, and the number of valence electrons for bromine we very well know is 7. Okay, so 7 electrons. So we have the valence electronic configuration for the halogens as Ns2, Np5. So 5 plus 2 is equal to 7 valence electrons. Then we have to find out the number of electrons which is gained from the bonded atom. So what is the bonded atom? Fluorine. We have 4 fluorine atoms which are singly bonded to bromine. So we have 4 number of electrons gained from 4 bonded fluorine atoms. Okay, now the total number of electron pairs. So we have to add this, the valence electrons of bromine. Then we have to add the electrons which are gained from fluorine, 4. And then we have to add the negative charge as well, divided by 2. So we have 6. Okay. So 6, and now the number of bond pairs. So we have 4 fluorines bonded to bromine. So 4 bonded pairs. And then the number of lone pairs, we have 6. Total number of electron pairs minus the bond pairs is equal to 2 lone pairs. Now, when we have a structure having the total number of electron pairs is equal to 6, then we have a typical octahedral geometry from the electronic arrangement. Now, this perfect octahedral geometry gets distorted when we have a lone pair according to the VSEPR theory. Then when we have these 2 lone pairs, then this octahedral geometry gets distorted to a square planar geometry. Okay, square planar means we have something like this. We have the central atom here, and then we have the 4 other bonded atoms. And at these axial positions, we have the lone pair. That is the square planar structure. Okay, now let's check out if we have a square planar option or not in this question. So first option says the third structure is tetrahedral. No. And the third option says the third structure is square planar. Yes, it is the square planar structure for BrF4 minus according to the VSEPR. So the third option, trigonal pyramidal for SO32 minus, trigonal planar for CO32 minus, and square planar for BrF4 minus. So that is our correct answer, this third option. Okay, so I hope this explanation was clear to you. Applying the VSEPR theory, how we calculate the number of valence electrons, then the number of electron pairs which are gained from the bonded atoms, then the total number of electron pairs, then the bond pairs and the lone pairs. And the presence or absence of the lone pairs will decide the final geometry of the molecule according to the VSEPR theory. Please like, share and subscribe if my videos are helpful to you, and please let me know what you want to learn next in chemistry in the comment section. Thank you so much.